Okay, this morning we're going to talk about perfect square trinomial factoring. One of the things you're going to notice about perfect square trinomials is that both of the first term and the last term will both be perfect squares. Okay? And so these can be rewritten as the product of two binomials that are exactly the same. So what you're going to end up doing is taking the square root of both the a term and the c term. That's the first term and the last term. The square root of the first term will be a and a, just like we've done in the x squared, x squared turned into x and x. And then the square root of the last term, which is b, will go in the last spot of each parentheses. And then as we've talked about signs, the signs here tell you they're going to be the same, and this sign tells you what they're going to be. Now that can also be rewritten as a binomial being squared, because there are two of the exact same parentheses. So that can be rewritten as a plus b quantity squared. So below that, we have something that's very similar. So here in the second problem, we have something very similar to that, except our sign is going to be negative in both of the parentheses. So a minus b and a minus b, so that we can write them as the product of a minus b quantity squared. So that's the pattern that is going to exist for the perfect square trinomials. When can I use this? When the expression has three terms, and the first and the last terms, as we saw, were perfect squares. The middle term fits the pattern of AB plus AB, or 2 times AB multiplied together. All right, let's take a look at some of the examples down on the bottom. So we notice that the first term and the last term of each one of these problems is a perfect square. Right? And then in the middle, that is an even number that can be rewritten as the same thing twice. All right, so let's get into factoring these. Once you recognize the pattern, or once you recognize that this is a perfect square trinomial, these are really fast because there's not a lot of thinking here. You take the square root of the first and the last term, so that's a3, and then it's a matter of just looking at the signs. So in this case, the sign is positive. In the b case, the sign will be negative. So we'll jump into that one. So x minus 10, x minus 10. Down here on c, we take the square root of both the a term and the c term. And we'll get 6x minus 1, 6x minus 1. And remember that this can be rewritten as 6x minus 1 quantity squared. And the last one on perfect square trinomial is 2x plus 5, 2x plus perfect square trinomials, you'll have two of the exact same binomials. And that is perfect square trinomials. Okay, now let's look at the difference of two squares. What you'll see in my class is that I will abbreviate this as DOS. Okay? So the difference of two squares. Your first term and your second term will both be perfect squares, and you have a subtraction in the middle. Now, the difference of squares, the difference of two squares, tells you exactly that. The difference word is your subtraction. So without subtraction in this problem, you can't do this method. And then the problem tells you there are two squares. So the a squared and the b squared are both perfect squares. So the difference of two squares is explaining to you exactly what's in the problem. So here's the pattern of the answer. You take the square root of both the a squared and the b squared, just like we did in the difference square trinomial. The a plus b, a minus b. So please note here, we have different signs. Okay? So let's go fill in some blanks over here. Alright, the expression only has two terms, so it is a binomial. The terms are being subtracted. And each term is a binomial. Sorry, that's incorrect. Each term is a perfect square. So we have binomials, the terms are being subtracted, and all of the terms are perfect squares. So what we notice on this is everything is a perfect square. It can be square rooted. Okay? What about 162? Well, we'll get there in a few minutes. So it's not a perfect square. There must be something else going on. Alright, let's jump into this problem. Alright, so the pattern of these problems is you have two parentheses, one with a plus, one with a minus. You have different signs. We're supposed to square root each term. The front goes in the front, the back goes in the back. So x squared is in the front, so x goes in the front of the answer. The 4 is in the back of the problem, so the square root of 4 goes in the back of the answer. And that is the answer to the factorization for A. Let's move on to B. Okay. Square root of x squared is x. Square root of 121 is 11. We need different signs. And that's it. Boom. Difference of squares is a very fast factoring as soon as you know what the square roots are. C. Alright, so C has a perfect square in the front of the problem. So please note that the 25 and x squared are together, so when you square root them, that part stays together. So you end up with 5x, and square root of 16 is 4. Different signs, one's plus, one's minus. You're going to find that I'm going to put my plus minus in the front every time, just as a habit. D problem. Square root of 64x squared is 8x. The square root of 1 is 1. Different signs, and we're good. All right, the E problem. What's in the front stays in the front. Take the square root of 36. 6 stays in the front. Square root of x squared. That's in the back, so it goes in the back. Different signs. Done. All right, on F, what you should notice is that these are not perfect squares. So remember, we're supposed to look for something first every single time, and that would be the greatest common factor. So we can't take the square root first. We have to factor out the 2 before we can start taking the difference of squares. So we remove the 2. That gives us x squared minus 81. And now you notice that both the x squared and the 81 are perfect squares. So 2 comes down with the rest of the problem. We get x plus 9, x minus 9. All of the problems were square rooted. All of the problems have different signs. That's difference of squares.